Look at the massive physical footprint of Elon Musk's industrial operations. We're talking about thousands of tons of steel climbing into the atmosphere and entire fleets of humanoid robots moving through testing facilities. But all of that heavy machinery is effectively dead weight without the microscopic logic engines required to tell it exactly what to do. This is a golden silicon wafer covered in a dense grid of advanced microchips. It is the specific physical object required to power this future. Right now, every major technology company is aggressively fighting over a strictly limited global supply of these exact squares. A bottleneck in these tiny components threatens to completely derail the timeline for colonizing Mars and deploying artificial intelligence at scale. The current standard across the tech industry is to design a chip, then outsource the actual manufacturing to a few massive, specialized foundries located overseas. This diagram illustrates the problem. Almost all American tech infrastructure relies on supply chains that funnel into a single island, Taiwan. That creates a massive geographic choke point. This image captures the posture Musk is taking against that vulnerability. He is actively pivoting his companies inward to establish absolute manufacturing independence. Securing that independence requires an immediate, massive capital commitment. The initial price tag to build an internal supply chain sits at over $25 billion. This is an aggressive corporate maneuver designed to completely bypass the established global semiconductor system. This is the Austin, Texas skyline, marking the exact geographic location where heavy tech manufacturing is being brought back to American soil. The scope of this new project, dubbed Terafab, requires the simultaneous construction of two highly advanced chip factories. To manage the steep technical learning curve of fabricating custom silicon, Tesla has formed a strategic alliance with Intel to help execute the complex build. The rollout is moving rapidly. Merely months after inception, the team is already deep in supplier negotiations, driven by a demanding, round-the-clock work ethic. This cleanroom environment shows the sterile, hyper-complex machinery this fast-moving team is attempting to piece together. They are attempting to compress decades of traditional foundry evolution into a few highly volatile years to beat the global shortage. The first, most immediate destination for these internally produced chips will be the millions of next-generation electric vehicles rolling off Tesla's assembly lines. This prototype is the Optimus robot, representing the second major end user. It requires specialized, low-latency processing power to interpret its surroundings and perform physical labor. The third, and arguably most ambitious, destination for this custom silicon is SpaceX. The plan involves launching AI orbital data centers, massive server clusters orbiting the Earth, which demand highly specialized, radiation-hardened chips to function in the harsh environment of space. The Terafab is designed to be the central nervous system, connecting ground transport, robotic labor, and space infrastructure into a single closed ecosystem. But building a massive, vertically integrated empire exposes these companies to profound financial fragility. This image of a technician under strict red cleanroom lighting illustrates the unforgiving nature of semiconductor manufacturing. A single particle of dust can waste billions in capital. With an extreme upfront cost of $25 billion, there is zero room for delays. Yield failure in Austin paralyzes the entire development schedule across all of Musk's companies, effectively severing the computational link between the robots, the cars, and the rockets. However, if the Terafab reaches high-yield production, the structure of Tesla and SpaceX completely changes. They achieve total vertical integration, a business model where a single company owns every step of the process, from the raw silicon base layer all the way up to the finished hardware. This rocket launch represents the ultimate expression of that independence. Multi-million-dollar aerospace hardware fueled entirely by internally sourced computational intelligence. Many investors remain skeptical of the massive upfront cash required to build these foundries before a single chip is even produced. This $25 billion gamble isn't an isolated factory build. It's an attempt to capture the operational efficiency and vertical control that a $1 trillion valuation demands.